yesterday we covered some things entirely into statistics, like standard deviation, CLT, and all of that. And also we tried to mix it with Python to see how we can leverage Python to do some checks. We tried to see how we can identify outliers, detect them, using IQR technique, and then eventually how to how to work on outliers, like how to delete them or get rid of them or those kind of things. If the number is less, then so before going into the details, so these are few of the things that we saw. So these are the basic things that essentially we need. Now stat has a lot of things to talk about, but that will eventually take years to learn, so we can pay our attention on the specific things we need as part of AIML, as part of machine learning. Whatever things we needed, we can probably cover those areas. So standard deviation is something that we have seen. Outlier analysis, something we have seen. Missing value is something that is similar to outlier, but just consider missing value. Now we have not seen anything like missing value in our data yet, but what if our data had some missing values into it? Let's say any of the columns, the province has some missing values into it. Now we cannot go ahead with missing value for any sort of ML operations. Missing value cannot be auto cured. You have to work on it, you have to fix it, and then only we can go ahead with it. Now this is kind of similar to outlier, because I mean, similar as in like the treatment, how we can fix it, that treatment is similar to an outlier. Because for outlier, what we do, if the number is less, if the number is, let's say, less than 1%, then we simply delete those observations. Let's say this is an outlier and this is an outlier. These are some outliers. Then we will simply delete this row. This entire row will be deleted. Same with the missing value. Let's say which one we were talking about, the province. Let's say this province is missing value. So this value is not there. Out of all the records, only this one is missing. So how much percentage is missing value we have? So that is the first thing that we have to identify. Now, how do we identify that? It's very simple. It's just one simple command. df dot is null dot right. Oh, there are some missing values. Great. So product base margin. So there is, so what this will do, so df is my data frame. Let's do step by step. df dot is null. Is null is a question. So I'm asking the data frame, do you have any nulls into it? So this is how the output is. So whenever there is missing value, it will tell me as true, else it will tell me as false. Now all these are coming false means there are no missing values. So all of them have some value in them. So the next step is what we do, we will try to do a sum function. So this will sum each and every column and it will tell me how many missing values are there. So it tells me this product base margin, this one has some missing values into it. This particular column, this particular dot value counts. Let's go details into it. Product value dot p type. So this is a floating point, and floating point has some this thing. Floating point has some missing value. So what is the total number of record? That is the first thing. Let's see that. 8,399. Out of how many missing values? Only 63. So if we do a simple mathematics divided by 8,399, and even if we multiply this with 100, we convert that into a percentage, this is what we are going to get. So less than 1%, 0.7% missing values. So 0.7% missing value. So there's no point of keeping these many number of records. We can simply drop it because we have sufficient data. But what if the number of records are less? Let's say we had 100 records, and out of 100, there are, 5, 6, 7 records which have missing values. Then in that case, it's better if we fix them on spot. So similarly, like outlier, missing values can be treated in two ways. Missing values can be treated in two ways. What? Number one, deletion, simply delete it, and second one is imputation or impute. So one is delete and impute. So delete means simply dropping that. Impute means you are not dropping it, you are replacing that value with something else. Okay, now for our case, we can simply drop it. Dropping these many number of rows would certainly solve the problem. So how do we drop it? So there's a simple command of drop na. So df dot drop na. Drop na within that axis equal to 0. Okay, let's simply do that. Yeah, drop na has been dropped. 8336. That is the final number of rows. So if I do a df dot shape now, 8399. So okay, no, so it has not dropped. So those many number of record has not dropped. So this certainly has not worked because the number is still same. No, hold on. 8399. What is the total number? df dot shape. Yeah, no, so the dropping has not happened. So 8399, it's still showing 8399. Okay, so df dot drop in it did not work, but ideally this is one of the things. This is one of the things that should have worked. Now let me specify for columns. Let's see if that works. Axis is equal to 1. So if you guys remember, axis 1 for columns and 0 for rows. But we need it for rows, so it should be axis equal to 0. No, but this has certainly not worked. Hmm, yes. Okay, so let's identify those records first. df dot base. Now, what are the missing values? So I assume these are dots. Missing should be in the dot ones. I'm assuming that is equal to something dot. No, they are not in dot. So this is the problem here, how to identify the missing values. So 63 are missing value into it. So how do I identify? Is it like np.nan or what type of value? So that is the main thing. One second, let me think of something. Is null. Okay, this dot is. That is a problem. If something, if you use a different function or something, it might take. Okay, no, this is what. Dot is null. Yeah, this is equal to. Now select only those where this is equal to true. Product base margin. Where is that column? Yeah, these are okay. Finally, we got it. So we identified the missing values using is null function, the one that we used to identify the actual overall missing values, we use the same function. But instead, we applied that function on that particular column specifically. And then we use the filtering condition that we have seen. If this is equal to true, then within the data frame, bring me those records. So this is the format .nan. So alternatively, can we do that? Yes. Now, if you guys remember, everything comes from NumPy. So if we have to access this, I have to call it in the form of this. So let's say if I want to access this 63 records separately, then this should be equal to np.nan. That could be another way of accessing, but this is not working. So np.nan is np.nan is certainly not working. These are the combinations. That is the n, n in capital, n in lower. No, it's not working. N in lower. No, I think that's the only way easily through which we can identify the missing values, is using this dot is null is equal to true. So these are the ones. So how we can easily do it? So let's do it easily using, let's create a new flag, and that way we can just call them up. Or there is another option that we have in Python. So it's like, so it's like if else condition. So if else we have seen, right, in Python. If there is something, else there is something. We have seen that already. What we are trying to do is we are trying to leverage that same thing in the form in the Python column, within Python columns. Like if one column is like this, then the next column will be like this. Something like that. Let me just recall it. So are you guys following what exactly I'm trying to do? Ranjit, Sian, any questions? So what exactly I'm trying to do here? Where exactly I'm struggling? So the main thing is identifying the missing values, because in Python, for characters, it pretty straightforward, because it will be a missing value. Like it will be, just a space and inverted. For characters, it will be just like this. So this means a missing value for a characters, but for integers, for floating point, for time, for other formats, this is the challenge that sometimes you have to face to identify the missing values easily. And identifying missing value is one thing, but to be able to replace it with a new value. To be able to replace it with a new value. So these are few of the things that you have to face sometimes. So TF, so this is one thing. This comma this, then if it's is equal to, just give me a moment. I'm just trying if this will work, and then I'll just explain what I did. So that if else thing I'm trying to do. If this works, if dot is null dot sum, this should have worked. No, this did not work. Unhashable type series did not work. Here, no, this is certainly not working. So what I was trying to do is I was just trying to identify the missing values and replace them with the mean value. So that is what my objective was, to identify the missing values and just replace them with the same column's average value. That's what I am trying to do. But this did not work, but okay, that's fine. Let's try out different techniques. What else? Using map, using apply. Apply is something that we have already seen, right? Apply is like this column is equal to the same one, this dot apply, and then within apply, what I want to apply? I want to apply lambda function, lambda of x. So what will be the value of x? The value of x will be this column dot mean or x dot mean if x dot is null is equal to true, else this is equal to true, then if it is equal to true, then replace, else don't do anything, else keep it same x. No, this has also not worked. Float has no attribute, is null. Okay, I should have it. TF. Okay, let me cover this sometime else here. I don't think it's right now. It's not working somehow. Let's not waste any more time. But these are few things that you will encounter every now and then. Like, and this is probably will take a lot of time. Like sometimes a simple, because Python has a tendency of reading. So whenever, let's say you are importing a CSV or Excel file, now a CSV has Unicode, various types of data elements in it. So it's possible that sometime it detects it in a different way and sometime it detects it in a completely different way. Dot is null, is null. True. No, floating has no is null. Floating, this gets treated np dot is if x dot n, if x is equal to np dot nan. No, this does not work. See, the number is still 63. So identify specific missing value is really a pain sometimes. It's no, still I'm not able to detect because the numpy type of missing values and the type of missing values here, so these are completely different. So it's has not been able to work. Last, let me try. This will work. Floating runtime, I'm trying to convert that into float. No, yeah, this has not yet worked. Okay, let's leave it for now. I'll see later how this can be tackled. So that is, these are ways of treating a missing value. So if the number is less, just drop it. Else, okay, let's simply try to drop it because the number is even less than 1%, right? So how can we drop it? Dropping means first you have to identify the elements. That is the first thing. So this technique will enable me to identify the missing value. 63 has been identified. So next will be df1 is equal to df and then not equal to. So this is one technique which we can use. So this sign, this is not equal to. So this type of, so this will be just top of your tab on your laptop. So this caps option will tell Python that the user want to nullify the condition. So here what I'm trying to do, I'm trying to select this particular condition, right? So if I place, this particular sign before it, that means user wants to reverse this statement. That means I want to select only the opposite of these ones and not the specifically this ones. So, and whatever result I will get, I will store it in df1. So then if I do a df1 dot shape 8336. So what it has done, it has essentially dropped those 63 records, because earlier I had 8399, now it has 8336. So 63 rows have been dropped, right? 63 rows have been dropped, and I can now go ahead with df1 taking as the main one. So I've been able to delete these ones. So that is one condition that we can do. Just take the reverse one. Now I could have easily used a false here, right? I could have easily used a false here instead of using this. That is true, but what if for situations where we have multiple values and we don't know what those values are? Let's say for a particular variable, I know if the value is 3, then we can delete it. But if the value is 3, if the value is 4, we should not delete it. If the value is 5, we need to do it something else. So the condition will be if 3, then only delete, otherwise keep it. So to tackle those kind of scenarios, we can use this operator. So that is how you can drop it. Now dropping part is done, but that imputation part is something that I have to check. So I have not been able to do it. But this is very much essential to do, because in a real world practical scenario, you will have lot of elements, lot of data columns which will be blank, missing value and all of that. So first thing is you have to do something like df.isnull.sum to see how many of them have missing values, how many of them have missing values into it. Based on the number, what you can do, you can just calculate. Okay, you can do it here as well. Dot sum divided by length of df. If I do this, it will just give me the same thing in percentage, and then essentially multiply it with 100 to convert that into percentage. So this simple thing will give me the details in a percentage wise. And then essentially what you want, if you want, you can convert that into a bar chart. So I can see only 0.7% is missing from a product based margin. Rest all have no missing value. So those are the kind of tricks we can play to make it visually good. Otherwise, going through numbers is really difficult. And sometimes if you have to convince that to the senior people, senior managers, then this would be the best way to do it in convince it in an easy way. So that is how you deal with missing value. Now, this is one thing I will see. Uh, Sometimes it works, sometimes it doesn't. So it really gives you a pain point sometimes. And in Python, because there are so many things, it's not possible to remember everything. But you should know the tricks. You should know what you should do. How you should do is something you can Google it every time. That's not a problem. But you should know at what how to do it or what to do it. What to do it is something that you should know, be aware of. Like if there is missing value, what I should do. That is something you should be able to answer. Like if the number is less than 1%, if let's say the missing values are in order, the name of the customer name, then that is something we can simply ignore, because customer name will not come in. It will not be any important criteria to detect or to come up with any modeling or statistical things. But if we are talking about profit, sales, discount, these are important variables. So we simply cannot delete them. We have to investigate how many percentage and all of that. So that is all about missing values. Next is correlation. We will see that right now, and the errors. Okay, distance matrix, this will come under the later part, and bias variance will come on later. It has nothing to do now. Probability basics, that we have not covered technically, but we have talked a lot on that. I will just tell you how. So probability, if you guys know, what is probability? So probability is the probability of something happening to something not happening. So that is basically the definition. Probability is the you know, the probability of something. So the probability, that means the percentage, the chance of something happening to compared to the entire, you know, scenario or something like that. So that is what a probability is. If I have to give an example, so let's say rolling a dice, you know, right? Rolling a dice. So if you roll a dice and let's say the dice is uniform, the dice is uniform, that means it's not broken, it's not tilted or something like that. How many outcomes you're going to get? Ranjit, tell me, Ranjit Osian, how many outcomes you're going to get from it? If you roll a dice, like what are the, you know, numbers you can see?
2, 6, 12, 1.
No, 12, how can you see? You're talking, we are talking about one dice.
1 to 6.
1 to 6.
Yeah.
Correct. 1, 2, 3, 4, 5, and 6. Right. So these are the outcomes. These are the actual values. But what is the number? The number is 6. These are the actual values. Don't get confused. These are the actual values. So what is, how many outcomes? Outcomes will be 6. And if I, let's say, roll a dice, and if I want to see number 2, then what is the probability I should get 2? What is the probability that I should get 2? So it will be written like P within bracket, that particular value that you're looking for. Let's say I'm looking for 2. Now, if I roll a dice which has these numbers printed on each sides, 2 will come only once, right? Like, let's say I'm doing it 6 times. First time I'm getting 1, second time 2, second, third time 3, fourth time, fifth time, and 6th time. So if I do this like this, so out of 6 outcomes, 2 can come only once. Like at one shot, I will get 2. Right? So the probability of getting 1 is 2 will come 1 divided by 6. That means we write it like actual occurrence divided by total space. Total space. So actual occurrence means it will come only 1 divided by total number of occurrences 6. So this will be my probability. So if you divide this, you will get something, some number. Yeah, 0.16 something, 0.16. That means there is a 16% chance, 0.1667 or something is equal to 16.6%. So if you roll a dice, then what is the probability you will get it to? The probability will be 16.6%, provided the decision has been taken randomly and the dice is uniform, and nowhere it's broken or tilted or something like that. Right? Hello.
Yeah.
Can you see? Hello.
Yeah.
Yeah, please respond. So are we good with this, or then only I will proceed?
Yeah, this is fine.
Ranjit?
How-
Ranjit, you understood, right? I think he has some doubts. He's not saying anything. Okay, we'll see what he has to say. So, meanwhile, what we can say is probability is the occurrence, is the probability of an event occurring to the total number of events. That particular event or actual event to the total number of events. So that is what the probability is. So the probability of, let's say, so okay, so this is a probability. So this value will lie between 0 to less than equal to probability of anything is less than equal to 1. So that will be the value of probability. 0 less than equal to probability less than equal to 1. So just remember this thing. Probability is something which value will never be less than 0. It cannot be more than 1. So it will lie between 0 to 1. If probability is 1 means that event is happening. Probability 0 means that event is not happening. So that is all about probability. So there are two things. Just remember actual event which is happening compared to total number of the possible event. Just divide them and you get the number. Another simple question, if I say, what is the probability that every time I will get a 4? So what is the probability that I will get a, let's say something else. Okay, let's take a step beyond. So let's say there, hello, Ranjit,
Yes, sir.
you lost or what? Okay,
Yeah,
so
suddenly I got one call from my client. That's
got
why.
dropped. No, that
Yes,
is
sir.
fine. So this probability we're talking about this one. So you have any questions? You understood, right, how this calculation is happening?
No, sir. Actually, I missed that part.
Okay. So probability is a particular event happening to the total number of events which can take place. It's just a multiplication of that.
Hmm.
Right. So
Okay.
what we are seeing here, so okay, don't get confused by probability 1, 2 or something. Let's try to see it with an example. So how can we do it? So probability. Okay, so let's say, okay, so this is a dice. So these are, let's say, the sides. These are the sides. So at a time, if this is a dice, we can see at a time only one side of it, right? We can, if let's say this is a dice, this square box is a dice, right? So at one time, we can see only one side of it. At one time, we can see only 2 or 5 or 6 or something like that. So if we roll it and if this is not broken, so can you see two sides of it? No, right?
Hmm.
You can see only one side of the dice and that will have any number printed from it. Now, how many sides it has? 6. So if you roll it randomly, any of the numbers can come. If you roll it randomly, if you don't, have a tilted ground or any such preconditions, you can get any of the things out of it. Hey, just give me a moment. My son just came. Nichija. Just give me a moment. Let me just.
Sure, sure. You take your time, sir. No
My
problem.
son just came. So
No problem, sir. Carry on.
hello. Yeah.
Yeah, yeah. Yes.
Okay. Yes. So the thing I was trying to say is okay. That is okay. So one of the 6 sides is something that we can see. So the total number of sides that we can see is 6. But if we roll it once, we would be able to see only one at one time. So what is the probability that if we roll it, we will see a 3? So it will be 1 divided by 6. It will be 1 divided by 6. Right? So that will be the probability of getting 1. The probability of getting any numbers, if not specifically 1 or 2 or 3 or 6, because we are not doing anything with the values here. We are going ahead with the outcomes. So the probability of any number coming at one point is that one divided by the total number of things that can happen. So that is the probability. One, that means that particular number. If I have to do it in some other way, let's say you are going to the market on a bike and you are taking a bus to come. No, this example will not be right. So one more thing. Okay, let's say a class of students, they gave an exam. So the class of, it has probably 50 or 100 students. They are giving an exam. And then we have been asked, tell me what is the probability that, they will pass or fail, or as simple as that. So for that, what is the probable? So the question is, let's say how many of them will pass, or they will either pass or fail. So that kind of a thing. So first we have to see what is the probability or total number of events. Total number events are 2. Students will either pass or they will either fail. So there are only 2 instances, right? It can happen in only 2 ways. Either they will pass or they will fail. Now at one point, if I say, so this value is 2. So the total number of events that can happen here is 2. It cannot be anything else. And out of them, if I say how many, so what is the probability that they will pass? So it will be 1 divided by 2. That means it will be 50% or 0.5 probability that, I don't know why it's like this. So it's like, 0.5 the probability is 0.5 that they will either pass or they will either fail. That is what probability is all about. So the actual event is happening divided by the total number of possible events. And that is how we calculate probability. If we go a level beyond, let's say right now we are talking about 1 dice. Let's say we have 2 dice, 2 dices. Let's say rolling 2 dices in uniform. So what are the outcomes? Now these are the outcomes. So dice 1 will be 6, dice 2 will get me 6. Right. So if I roll a dice once, what are the possible outcomes I will get? So the first outcome could be 1, 1. So both is giving me 1. Right. The second outcome could be 1, 2. The third could be 1, 3. Like that. 1, 4. 1, 5 and 1, 6. Okay. That is one thing. What more could happen? 2, 1. 2, 2. 2, 2. 2, 3. Like that. You're getting my point. So every time, if I'm rolling a dice, these are the possible combinations that could happen. 6 will go in 6 different ways. So on a total, how many can we expect? We can expect 36. Right? How many can we expect? We can expect 36. Is it getting confused? Or I'll take probably some more simple examples.
6, how it comes 36? Outcomes only 1 die it is using, no?
No. So if you are, just imagine there are 2 dices.
2 dice means,
Now,
okay, understand.
yeah, it's 2, right?
Yeah, 2 dice means 36, okay.
See the combination. So that is the combination. If you roll it once, one number will be printed on one, another number will be printed on another. These are those numbers. So one dice has 1, another dice has 2. One has 1, another has 2. So these are the possible combinations. Now 6 and 6, how many possible combinations it will have? 36. So my total number of events will become total events will become 36. That means the denominator will be 36. Now comes the numerator. What exactly I want? Suppose I have been asked that, every time, what is the probability that you should get a 6? The sum of both dice should be 6. Now you have to see what are the combinations which will give you 6. What are the possible combinations? So one combination could be 1 and 5, right? Another combination could be 2, 4. Another combination could be 3, 3. Right? The next combination would be 4, 2. And the next combination would be 5, 1. So if these are the combinations that we take, this will give me 6 every time. Out of all 36, only for these, we will get a 6. Right? The sum will become 6. If there is 1 in one dice and 5 in the other one, the sum will be 6. If there is 2 on one, 4 on other, then the sum will be 6. If for 3, 3, the sum will be 6, like that. So the total, the actual number of events will be 5. Actual number of events will be 5. So the probability that you are getting a sum of 6 every time you roll a device will be 5 divided by 36. That is the probability. So 5 divided by 36 will give you 0.138. That is your answer, 0.138. That means 13% basically. 13.8%. Understood? So that is how we calculate. So this is a question. Let's say 2 dices were given and you have been asked what is the probability that you will get a sum of 6. So I have a 13% probability that if they are rolled randomly and uniformly, I will get a 13% chance that you will get a sum of 6. So that's one of the simple examples of it. If we take some other examples, let's say now we are talking about coins. Now for coins, what is the probability that you will get a head for coin? For coins, what is the probability that you will get a head? Now for coins, what are the total number of cases that can happen? Only 2. Either you will get a head or you will get a tail. Unless the coin is damaged, it will not fall properly. That's a different thing. But if you go ahead with this condition that the coin is proper, they is not broken or something, then total outcome will be 2. Now, if I ask you, what is the probability that you will get a head? The probability will be 1 out of all the probabilities, which is 2. So it will be 0.5 or 50%. That means if you roll the, if you toss a coin 100 times, let's say randomly, there is a 50% probability that you will get a head and 50% probability you will get a tail. Now, for situations where the binary, the outcome is 2, in that case, the probability of 1 will be 1 minus other. Because what we have seen earlier, probability's maximum value will be 1. So if probability of, let's say, probability of you're getting a head, probability of getting a head is equal to 0.3. That means what is the probability that you will get a tail? So that will be 1 minus probability of head, which will be 0.7. So that is how this operates. Or in other way, you can say the probability of all events, event A1, then, plus probability of event A2, all the probability sum will be 1. So we can leverage that particular formula here. Now, this is important. This simple probability concept is important for later classifications and those kind of machine learning, deep learning problems. right? That is one simple example of point. Let's say cards. So these are standard examples of probability. So if you take cards here, card has how many into it? 52, right? A card, a deck of card has 52 cards in it. So the total number of outcomes mostly will be 52. Now, let's see the question. Let's say the number of aces in a card. You know, right, what an ace is? Or number of kings in a card or something like that. In a card deck, if that is the question, uh, then your number of decks will be 4. So what is the probability if you take a card from a deck that it will be ace? Its probability will be, so P will be 4 divided by 52, 1 divided by 13, which is equal to how much? 1 divided by 13, which is 0.076, 0.076. So this will be the probability. So if you take one ace from randomly from a card of deck, the probability that that particular card will be an ace is 0.076. Right? Is that clear? So that is something on probability. So I'm not going any more deep into it because it's eventually a lot of things are there in probabilities. But yeah, understand this is the thing. Now, an important thing is probability distribution. Let me just show because I don't have anything. Probability distribution. Now you would be able to relate to this. You would be able to. A probability distribution is an idealized frequency distribution. So basically what is a probability distribution? Because this is something that we have seen already, which we call a normal distribution. Normal distribution is essentially a probability distribution. What is the probability that, or how the shape will look like, how the distribution will look like, distribution of all those terms. It is the number of times each possible value of a variable occurs in the data set. The number of time is determined by the probability of occurrence. So that is what we have been doing until now. Like this is one hist plot. This is one example of a probability distribution. And similarly, this one. So these are like how many elements that now these are actuals. These are not, something which we have predicted. These are actual numbers that we have. And that is why, that is what this is all about. So the terms that is coming into the database, it's the number of times each possible value of a variable occurs in the data set. If we put that in a distribution, we will call it as a probability distribution. Now, in statistics, just let me just touch base on one thing. Distribution in, there are lots of distributions available. Just let me take one example and just show you quickly what I'm talking about. So there are various types of distributions available. Yeah, like this. So this is the normal distribution that we have seen, where the mean should be at 0, at 0 standard deviation, right? Yesterday we were talking about if all the values lie within 3 standard deviation, there is this percentage, 68% within 1 standard deviation, 95% within 2, and all of that. So that is all normal distribution that we talked about. T-test distribution is something whenever your number of values are less than 30 or a smaller distribution you're talking about, then it's only t-test. And I mean, these all things are good to know, but not really very much beneficial for our work. Binomial distribution, whenever you are talking about two outcomes. Let's say this example, head or tail example we saw, right? For a coin. For coins, we are showing head or tail. So let's say if we do this operation for 100 number of for 100 times. So every time we will get a different probability value. Or let's say the card deck one. If we do it multiple, so we will get multiple. So if we put all of that into a plot, it will take the shape of a uniform binomial it will take the shape of a binomial distribution. So these are the different types of distributions we have, but mostly understand what a normal distribution is, because this is one we would be needed. Because normal, if the distribution is not normally distributed, then there is some problem in the data, you have to fix it. Otherwise, it's just you're lucky that your distribution is normal. You can go ahead with it. Right. So that is all about distribution. That is all a bit about probabilities. So probability is important, certainly. And this is all about probability. Bias variance, there is time, missing value, correlation. Okay. Let me now enter into correlation. So what is correlation? Correlation is something correlation, correl, correlation. That is the name. So correlation is what? Correlation is basically the relationship between two or more than two variables. Example, how one variable is influencing the other variable. What is the correlation? So let's say, let me create some random variables. Let's say this is height, or let's say this is age, and this is weight. Let me create some random values. Age is 20, let's say weight is 45. Age is 25, the weight is, so these are the weights 30, 32, 35, 45, 55. So 25, 48, I'm just putting some random numbers. 55, 60. So let's say I've given some random numbers. If the age is this is the weight. Some random this thing. Now, if let's say I have this type of data for 1 million records, so it's not possible to check manually if these two are related or not. Then I will take the reference of correlation. Correlation. Now, Excel also has a correlation. So see, correl, this is the name. So returns the correlation coefficient between two data sets. So if I do this, it will ask for array 1. This is my array 1, comma, array 2. This is my array 2. Close it. And it will give you a number. Oh, it's pretty high. It's 98%. Now, obviously, because we have manually created the numbers, so it's a high correlation. Now, what that means? Correlation means how these two are connected, how one variable is affecting the other variable. So the age variable is affecting the weight variable by 98%. Or we can say it otherwise as well. The weight variable is affecting the age variable by 98%. Right? So you understood that, right? Sian Ranjit?
Yes.
So basically correlation means the relationship between these two. The relationship, like how these two are connected, how one variable is influencing the other variable. If these two are correlated, that means linked, and let's say the percentage, now correlation is something which will value between -1 to +1. -1 to +1. Correlation. Now let's come to one more thing, which is Pearson. Okay, it's not going to Pearson, but all those correlation we are talking about, this is how linear connection we have between two variables. Now, linear connection means if we plot them into a graph, we can see, we can derive a straight line out of it, right? Now, it will not obviously be an exactly straight line, but to some extent, we can derive a straight line out of it. We can derive a straight line out of it, right? So that means this straight line indicates these two are kind of, they somehow are linked and there is a positive correlation between them. Now, what is the positive correlation? The positive correlation is 98, 0.98. 0.98 is the positive correlation between them. Now, 0.98 is, is a positive number. Number more than 0 is a positive. So 0 to 1 means it's a positive line from 0 towards 1. 0 to -1 means the more the number towards 1, that means it's a straight line. Now, let's say if the number is right now we are getting at 98.23, but if the number was, let's say, 45%, that means these two have very less correlation between them. What type of correlation? Linear correlation. Linear correlation. Now, if let's say, if I create these numbers randomly and see if this works or not, and if I create these numbers randomly, equal to random between something like that. So this is what we can see. What is the linear connection between them? So the correlation function says there is a minus 30% or minus 0.3 correlation. That means these two are correlated, but in a negative way. What do you mean by that? The negative correlation means if we increase the value of age, the weight will go down. If we increase the value of weight, the age, so increasing one value will decrease others. That is what a negative correlation means. Is that making sense? Hello?
Come again. I didn't get it.
Huh?
Come again.
What? So what exactly is the doubt? So where do you think you're not getting?
That linear connection.
Linear means what? Linear means line.
Mm.
That means if the connection between them, how linear they are, how much line they have. So think from 0 to 1. 0 means no linear connection. 1 means there is a highly linear connection. Linear means line. If you plot all those points, can you draw a straight line? That is what the linear term means.
Okay.
That is what the linear term means. So here, let's ignore this part. Now, this is the actual plot. Based on this, this is the actual plot of height and weight. So what we can see here is the points are pretty much scattered. So I cannot take all the points and create a straight line or something like that. But the last time, the values that we had, it appears to me like a straight line. Right? So that's what the difference is. So the more scattered there, the more split there, that means the correlation between them is less. That means one variable affecting other is less. And the more linear they are, that means the more, one variable affecting other, that value is high. As simple as that. Okay, let me give a practical example. Sian, you are in your final year college, right? So let's say there are two variables. One is time to study, and the next is scores in exams. Scores in exams. Now, what type of correlation do you think we have between these two? Just understand this. 0 means no correlation. 0.5 means medium correlation. And 1 means high correlation. So time to study and score, this should fall somewhere in this range, right? Because it's obvious, the more time you study, the more chance you of getting your high scores, unless you're using some other methods of scoring numbers. But these two are directly linked. The more time you will give to study, there is a high chance that you will get more scores in the exam. So these two will essentially be a straight line into a positive direction, because these two are positively correlated. The more you will, this value increase, this value is also increase, this value will decrease, this value will also decrease. So that will be a positive correlation, and it will fall in the range of, let's say, 0.5 to 1, or at least it will be 0 to 1 range, more than 0, less than 1. But let's say another example, chance to fail. So what do you think the type of association between these two? It's inverted. The more time you will study, the less chance you will fail. The less you will study, the more chance you will fail. Right? So these two will be in that same correlation, but into the negative side. So this could be a highly negative, linear correlation. The correlation could be high. Let's say if I have the data, if I bring the correlation value, let's say I will get 78 or 80 or 90%, but the value will be negative because one value is increasing, is one value is decreasing. As simple as that. That is how you have to remember it. So increasing one value will essentially decrease another value. So that is what this correlation is. Now, mathematically, if I have to put it, mathematically, how will I put it? Let's say this is time to study. The variable is t, and this chance to fail, the variable is f. So if I want to calculate f, how will I do it? So t is equal to f into, for this case, there will be a negative value. Let's say some minus 0.89. That is how you will be calculating the chance of fail. Okay, let's ignore this part. Let's come back to age weight. So this is what we have seen, right? Or yeah, this is what we have seen. So the age value and the weight value has a negative correlation, minus 30%. So if we calculate, now how to calculate is something that we are not going into it, but if we calculate the values, we will see, there are something which are coefficient. Coefficient means the value through which we will multiply this to get this. If there is a relation between them, I have to establish that relation mathematically, right? If there is a relation between two, age and weight, I have to age and weight. Let's say these two are linked. So how can I establish the relation between them? The relation has to be like age, like how we do it in mathematics? x1 plus x2 is equal to y, something like this, right? That is how we establish a relation in mathematics. So same thing we need to do here. So if we want to calculate or see the connection between age and weight, this is how we will do. So age is equal to some value or let's say weight is equal to, there is some value which we call as coefficient into age. So that will be the mathematical equation. So for that, the first thing is I have to see if these two are correlated or not. If these two are correlated, so first thing would be I have to see if they are correlated or not. If they are correlated or linearly correlated or not. If they are linearly correlated, next we have to calculate the coefficient. Next would be we have to calculate the coefficient value. So once we have the coefficient value, if we plug in that value here, let's say the coefficient value is, let's assume the coefficient value is 0.1345, something like this. So then this will establish the equation between this. So weight is equal to 0.1345 star age. So if let's say this is the equation, now this will help me to predict new values. So how much I said the equation was 0.1345. So if a new age is given, this is equal to this star this. That will be my equation. So let's say I want to calculate the age of 40. So that is how it will give me the prediction. That is how it will give me the prediction. Okay, now let me go back to the actual one. In that case, it will be the one that I built that time, where these were actually connected. So I think this is the one, right? Yeah, linearly correlated. This. See, the equation that we can see here, let me write it down. What is that equation? Y, which is weight. It has considered weight as the variable, that's value we need to calculate. So that is weight. So weight is y and x is your age. So how do we calculate weight? So we can calculate weight based on 0. This value 6517. So that is my 0.10. Something happened. Yeah, this value. Yeah. So 0.7457453. This one. So the weight will be 7453 into the age plus 30.661. This will be my equation. This will be my prediction. So all I need to do is just fill these numbers. So I want to see what will be the weight if the age is 51. It will be 68. If the age is 41, what happened? This, it has not. Oh, sorry. T11 has to be fixed. Yes, now this will work. Right. Oh, sorry, the G12 value will remain constant. Yeah, this value will remain constant. Right. So every time we change the value here, it will give me a prediction of how much we can get out of it. So understand how this works. First, what we saw. So these are the data that we had initially. First thing what we did, we tried to see what is the correlation between them. That means how one variable is affecting others. We saw the correlation is very high. It's 98%. That means one variable is heavily driving the other variables. This is more of like, the press the lever of your, car, more the speed it is. So that is a linear correlation, right? So you press the speed, it will not slow down. It will, of course, the speed will go up. So that is a positive correlation. But what is the example of a negative correlation? Brake and speed. More brake you press, the speed will come down. You release the brake, the speed will probably come to normal or something like that. So that is a negative correlation, but this is a positive correlation. So once we were able to identify the positive correlation, then we tried to see what is the equation. Now, this is what? This is linear correlation, linear regression. This whole thing which we did, this is known as linear regression. Now, I will go details into it later, but understand how it works. If these two are correlated, now these variables are correlated. If these variables are correlated, what it will tell me? These variables are correlated. If these are probably, I'll try to fit a straight line through it. If that straight line is able to pass through more or less all the points, then it will give me that flexibility that, okay, I have to find what is the equation between them. Now, that is something that we will learn later. How are we deriving to this equation? That is something we have to learn. This equation is linear because it is a straight line. If this is not linear, then what type of equation this would be? It could be a logarithmic, it could be exponential. If I put a exponential, this will take the shape of a curve. Okay. For polynomial, it will be slightly nonlinear in shape, but see the equation has also changed. X square plus x or something. R square 98. Something like that. Something like that. But instead, what we try to do, we try to see the linear. That means if I put all them in a straight line, what is the probability that this will fall more or less close to the line? So this equation gives me this value. Now, what is this x and y? X is basically my age and y is my weight. I want to calculate weight based on age, because these are linearly correlated. If they were not linearly correlated, I don't know if I would have been able to get to this equation so easily. But because they are correlated, Excel calculated that, give me that equation. So 0.7453 and 0.662, these are the coefficients. Now, what do we call it? Their intercept and slope, that will come later, but this is the coefficient that we calculated. The relationship link between these two, and that's the same formula that I applied here. So G11 is that coefficient value, then you multiply it with age and then add this 30.661. This is another intercept value. So this is the line equation. So if we put this line equation, it will easily give me the option to predict the unknown values, the values that we don't know. The values that we don't know. Right? So any questions until now? Ranjit, Sian, any questions?
No.
Okay. Now, this whole thing is all about a linear regression. This whole thing that we did, this is a linear regression where what are the things we did? Understand this thing, this small thing, listen it very carefully. So first we have some actual data, some actual business data that customer will give you. In a real world, what will happen? Customer will give you a real data. You will consider that as your training data. We will call it a training data. So the first things are, you will see the things that we have already seen, the number of rows, the distribution of age and weight, if there are some missing values, those kind of things. If you know, if there are any outliers or not. So those are few of the things that you will check. Okay. After that, the next thing is you will see the correlation. Now, if I show it here quickly, this is the one, right? Now, df dot for. DF of sales and profit. DF of sales profit. This dot or this. Now let's make it more beautiful. Heat map. This and not this one. And what is it? True. Good. And C map is equal to greens. Oh, beautiful. Now see what is happening. Until now we were in Excel. Now we want to see the same correlation in Python. This is how we are doing it. This is how we are doing it. We have selected only 2 columns from the data frame, and this is the function. The rest of the things are only decoration. Heat map and all of the things are decorated. But this small part is just the calculation. So what it tells you, this will give you a cross table. And with sales and profit, what is the correlation? Now, sales and sales is 1, obviously, because this is the same variable. So the same variable will have a same, it's essentially the same numbers, right? So the correlation, if I consider it twice, the correlation will of course be 1. There's no point of doing it. But sales and profit, we are seeing it as 0.58. That means 58%, which is very good. Not very good, but at least it's better. Not compared to our example where the correlation was 98%, because of course these are man-made variables, but this is on a practical case, and 58 correlation is actually a good correlation between sales and profit. So what we can do it, we can probably leverage this concept here, and based on sales, we can predict profit, or based on profit, we can predict sales. That is something that we can do easily. And that one, whenever 2 numbers are connected, now coming back here, whenever 2 numbers are connected, that is known as linear regression. Now, what we saw, so we did all those checkings, we saw the linear regression, now this thing, the correlation, which is a linear connection between them. So once that part is done, then we try to plot them into a graph. Now Excel has all those abilities, it can do it easily. So once they all been plotted here, I am able to get the coefficient values, which is 0.745 and 30.661. If I plug them here, I'm able to get a ready-made equation, and I can predict the future values. The age which I don't have, I would be able to predict what could be the weights out of them. Now, for an ML, these are the trainings and these are the final test that is happening. So how do we essentially, so after doing this, do we say that this is done? No, we have to do the error analysis. We have to do the error analysis. That means these 2 parts, classification error and regression error. So based on these errors, that's when we have to select that whether we are getting the correct values or not. Like if you do it here, instead of D4, right? So here, see what it's doing. So this is actual weight And this is predicted weight and errors. How much is the error that we have? Actual minus predicted. These are the errors that we are getting. These are the errors that we are getting. Now okay, let's ignore that. So these are the errors that we are getting. So what is the average of all those errors? The average is close to 0. So the more the average is close to 0, the better model it is. Right? The more this value is close to 0, the better model it is. Because obviously, for, for all the cases, you are not going to get the same result, right? The prediction, because that is what? This is a prediction. It cannot be the exact value. But at least I am coming close. Actual is 52. This model is giving me 53. Actual is 60. I'm getting 56. So to some extent, I'm close. Sometimes it's going up, sometimes it's going down. So if I average them out and this is my value close to 0, that means I can say that this model is actually pretty good model. This is actually a decent model that we have built. Right. So if we just make it whole, the error becomes 0, which is actually a brilliant thing. So that means your errors, what you are going to get, eventually they will be 0. So which is actually good. The average of errors will be 0. But yeah, so this is one thing, errors that we will cover later in details. And also we will try to see how this whole thing can be done in Python. But understand this, what a correlation is, how can we establish a connection between them, right? And how can we select one variable to predict another one, and then eventually create that equation and finally do the prediction and errors out of it. So in short, this is a small miniature version of an actual machine learning problem. In a real world machine learning, this is what you are going to do. You will be given this data. You have to come up with an equation. What is the equation? This is the equation. You have to come up with an equation. Based on that equation, you will see how much errors you are getting. If the errors is good and it's really better, then this is the model that you will build. So this is known as a model. This particular thing we will call it as a model. Right? Any questions? Hello.
Yeah. No.
CM Ranjit, any questions here?
No.
So you were able to follow, right?
Yeah.
Okay. Okay. All right then. So we will be covering this, and bias variance trade-off will come after that.
Okay.
After this error, then this one will come. Bias variance trade-off.
Okay.
So yeah, so that is something that we have seen. Correlation. Now in Excel, how in Python, how can we do it? Just using CORR. Okay, now let me just do it without using the colorings. Just keeping it simple. If I do it, this will be the correlation. So I have selected two variables. I could have used more. What are the variables I have? Order quantity. Order quantity. Yes. So see, order quantity has very little correlation with sales and even less correlation to profit. Now, these all are linear correlations. That
Okay.
means maybe order quantity and sales are impacted. And of course, the more the order, the more sales will be. But the number is only 22%. That means they are not linearly correlated. Linear, the line that we try to see here, this line. So the advantage of having a line is you can easily derive an equation. But if the line is not there, if these points are not forming a straight line, then you have to do some techniques to be able to create that equation. That is the only difference. But these are somehow correlated. So that is one thing. Now, having this correlation is not only a good thing, but also there's a bad thing also. Now we will come on those things later. Let me just write it down, otherwise I'll forget. Multi-collinearity problem. We'll cover that later. But yeah, this is what this has been a few inputs from statistics which we need as part of AIML. And that's it. Rest of the things will be entirely on Python.
Okay.
So from Monday onwards, we can take a real data. We can try to build a. Okay, first we will explore these 2-3 things. What is classification? What is regression? You guys remember, right? We said
Yeah,
that.
Yes.
So once that thing is finalized, then we will see this bias variance trade-off. That will come later. That's not an important thing right now. But yeah, thank you, Ranjit. Thank you, Sian.